mathematics class. Now today this class is for class 9 and we will be starting with a new chapter, that is circle, right? So first of all we will learn the basic things that are there in a circle. So the very first thing is, what is a circle? How can you define a circle? So what is a circle? Circle is the set of all the points. Suppose these are so many points which are forming a curve or a line or whatever you can say. So circle is a set of or a collection of points. You can say circle is a set of points. What type of points are they? Circle is a set of points, and what type of points are they? That all the points are at a constant or a fixed distance, such that all points are at a fixed distance from a fixed point. Set of all the points, all these points which lie on this line or on this curve. So these are set of points, and we know that all the points are at a fixed distance from a fixed point. Fixed point is this, let us name it as O. So this fixed point O is known as center, and from center you draw n number of lines. Anywhere you join them, so they are all fixed. Now let us say A, B, C, D. So distance of OA from O to A is same as distance of O to B is same as O to B, O to C or O to D. All these distances are same. So this fixed distance OA or OB or OC or OD is known as radius, and it is represented by small r, radius. What is radius? Radius you must have learnt in the smaller classes, that radius is a line joining the center of the circle and to any point on the circumference. So this is known as radius. Now whichever points lie inside the circle, maybe inside the circle or on the circumference, they are on the interior, and the points which lie outside are in the exterior. One more thing, that radius is always positive. In any case radius cannot be negative. None of the circle can be made with radius minus 2 centimeters or minus 5 centimeters or something like that. So first of all, what is a circle? Circle is a group or collection of points or a set of points which are always at a fixed distance. Fixed distance means that fixed distance is known as radius, which are always at a fixed distance from a fixed point, and this fixed point is known as center. We call it center. Center is represented by O in this diagram, and radius is OA or OB or OC or OD. This is all radius, radius and radius. Now this was the basic definition of a circle. Now we move on to the chords and diameter. We will just understand what is chord, what is a diameter, what is a secant, what is tangent, and so many things. Now the next topic is, now we will discuss about the chords. So what is a chord? A chord is a straight line which joins any 2 points on the circle. Suppose I take a point P over here and I take a point Q over here. So if I join PQ, so this line is known as chord. Why? What is a chord? Chord is a straight line, or a chord is a line segment which joins any 2 points on the circle. So I have taken 2 points P and Q and I have joined. So this line is formed. This line will be known as chord. Now if this chord passes through the center, means suppose this point Q, instead of lying at this, suppose this point Q lies at this point. Now this line PQ passes through the center, we can see, though PQ is a chord. First of all, chord, we know what is chord. In this first point, PQ is a chord. What is a chord? A line, a straight line joining any 2 points on the circle. Any 2 points on the circle. So this is a chord. Now, but if this chord passes through the center, condition is there. Suppose this PQ chord is stretched, and in any case, if it is made something like this, that it is passing through the center, then this chord will be known as diameter. Diameter. So diameter is also said to be the longest chord in a circle. So diameter is the chord, but it is the longest chord. And what is a diameter? A chord which passes through the center of the circle. Diameter is equal to 2 times of radius, because from O to P will be R and from O to Q will be R. So total length will be 2 times of R, and it is represented with D. D stands for diameter in the circle, and diameter is 2 times of the radius. You can see O to P is the radius and O to Q is the radius. So total length PQ will be R plus R, that is 2R. So that is why this is known as diameter. Now if this PQ line is extended or shifted to this point, let us say this point, so it will be something like this. Now the P point will be somewhere here and Q point will be somewhere here. Suppose this is the length of the PQ and I have extended it to this point, so Q will be out of the circle. At the same time, point P will also be become out of the circle, but still it is a line. So this type of line is known as secant in the circle. Secant in the circle means a line which is not a chord, but it divides the circle into 2 different parts or 2 parts, is known as secant. In this diameter, what it is? Diameter divides the circle in 2 equal halves. This is also one property, that diameter divides the circle into 2 halves or 2 semicircles. Now this is secant. Secant is a line which intersects the circle, let us say PQ is a secant which intersects the circle at point X and point Y. So PQ is a secant. What is a secant? A straight line which intersects the circle at 2 different points. Here PQ is a secant which is intersecting the circle in points X and Y. Suppose I take this PQ outside of the circle and I draw a line something like this, which is just touching the circle at one point. This is PQ, and let us say it is touching the circle at a point T. Then this PQ will be known as tangent to the circle. The same line will be known as tangent to a circle. Now what is the meaning of tangent? Tangent is a straight line which touches the circle only at one point. Only at one point. Means suppose I take a circle and suppose this is the circle and a line something like this is drawn. So it touches the point only, it touches the circle in only one point. So this will be known as tangent, and this is the circle. So now let's see. So I hope these things are clear to you. Now we come to the arc and segment and different things. I will come on to the segment. Now what is segment? If there is a circle and a chord is drawn, chord means a line joining any 2 points. So this chord divides the circle into 2 different segments. This is first, let's say this is second, or this first is second. Now the smaller part is known as smaller segment. This is a segment, and the bigger part is known as major segment and minor. This is the minor segment. and this is the bigger part is known as major segment. Segment. What is segment? If a circle is divided into two parts by a chord, then or you can say a chord divides the circle into two parts, those are known as segments. The smaller one is known as minor segment and the bigger one is known as major segment. Now similarly we will talk about arc. What is the arc? Arc is a, suppose this is a circle, arc is a continuous piece of a circle. Let us say AB. Now when we talk about AB, AB is this much of the circle, a continuous piece of circle is AB. So AB will be considered as arc and we write it as AB, arc AB. Now this is one arc AB and another arc is this one, the bigger part. So the smaller part is known as minor arc, and the bigger one is known as major arc. Major arc. Arc, what is the meaning of arc, or how will you define arc? Arc means a continuous piece of circle. Suppose I draw something less than semicircle and name it as PQ. So this is your minor arc because the rest part will be greater. So this is the major arc, this is the minor arc, and so. Now next topic is sector. What is a sector of the circle? If there are two radii, suppose I say this is an arc AB. Arc means continuous piece of circle. So this arc and these two radii, whatever area they enclose, this area is known as sector of a circle. Since this is a small part, so this is a smaller sector, whereas this is minor sector. We name it as minor sector, and this is major sector of the circle. This is the minor sector and major sector. What is a sector? Means an arc, whatever area arc encloses along with two of the radii. So this total area is known as sector, or this total. This is also two radii and one arc. This is the major arc. From A to B, if you move like this in clockwise direction, so this total area, when this total arc and these two radii, it will be something like this. This is a major sector, and at the same time if we talk like this, this is the minor sector of a circle. Now next thing is angle subtended by an arc. Now same thing, what is angle subtended by an arc? Arc and its two radii, this radius and this radius. These two radii, whatever angle they form at the center, this is known as angle subtended. Subtended by an arc. By an arc. And complete arc is known as circumference. This complete arc, if we talk from B to again A and B, or B to A and again B, this is known as circumference. This complete arc is known as circumference. This angle made at the center is angle subtended by an arc, or in the major sector, this angle is also the angle subtended. If we talk like this much, so this angle is also angle subtended by the arc. Now we have finished with the introduction to the circle, means whatever was important, arc, chord, segment, sector, that we have discussed. Now we will start with chord properties of circle. This is very important, and all these properties will be used in solving the question. So it is important, or it is mandatory for every child to learn these theorems. These are the theorems. To learn these theorems, because these theorems will be utilized in the questions. So first of all, I have written the statement. a straight line drawn from center. I have written it short. A straight line drawn from center. Center means center of the circle. So what I am doing? I am drawing a circle, and in this circle what I have taken O as center. Now what do they say? A straight line drawn from center to bisect a chord. It means there is a chord. According to the statement I am drawing the diagram. So what do they say? A straight line drawn from center to bisect a chord. It means in the question or in the figure there has to be a chord. So I have drawn a chord, though there has to be a chord. Now it looks like a circle. Now I have taken a chord. Let this chord name be P and Q. Okay. Now they say a straight line. This is the center of the circle. A straight line drawn from the center to bisect a chord. This is a chord, and the straight line drawn is bisecting. Let us say this point is M. M point is the midpoint of PQ, or you can say that PM and MQ are equal because it is given in the statement. A straight line drawn from center. What type of line is this? To bisect a chord, means this straight line is bisecting the chord. Then it is perpendicular to the chord. You have to prove that this line is perpendicular to the chord, means this angle has to be 90 degree, either this angle has to be 90 degree. We have to prove that. Now with the help of the statement I have drawn the diagram. Then you have to write the given, what is all given. In this I am not writing what is given. Now I move on to the next step, to prove. So what we have to prove? We have to prove that OM is perpendicular to PQ. It implies that angle OMP is equal to 90 degree, or you can prove OMQ also 90 degree. Either this angle or this angle should be 90 degree. So this is my proof. Basically my proof was this, but that can be written in this form also. So I have written it in this form. Now we have to do some construction. So what construction we can do? We can join OP and OQ. OP and OQ. So I am joining OP like this, and OQ has been joined. Now we got two triangles. One is PMO and one is QMO. So we will take, now we are moving on to our proof part. In triangle PMO and triangle QMO. Now in these triangles we have to prove that this and this angle is 90 degree. We know that OP and OQ are equal. Why? Because these are the radius of the same circle, and we know that radius of a circle are, or radii of the circle are equal. Radii means the plural of radius. So all the radius are equal. OP, OQ and whatever if I draw, all the radius will be equal. So first thing we can say that OP is equal to OQ. Why? Radii. Simply you will write radii. It is understood because you can see that common center is there. O is being reflected. So OP and OQ are the radii. Number one. Number two, we can say that PM is equal to MQ. It is given. What is given? They say a line, a straight line drawn from the center to bisect. The word bisect is there. According to that we said PM and MQ are equal. So PM is equal to MQ. It is given. Third point, we can say OM is equal to OM, common. This line, this OM is common in first triangle also as well as second triangle also. So we can say that therefore triangle PMO is congruent to triangle QMO by SSS congruency rule, by SSS or side congruency rule. Now if the triangles are congruent, then we know that all the 6 elements of first triangle are equal to the corresponding 6 elements of other triangle. So we can say angle PMO is equal to angle QMO. So we can say therefore angle PMO is equal to angle QMO. What reason? CP/CT. Next, but we have to prove that they are equal to 90 degree. We can say that angle PMQ is equal to 180 degree because it is a straight angle. We can say angle PMQ is equal to 180 degree. Why? Because it is a straight angle. But angle PMQ can be written as PMO plus OMQ. So angle PMO plus angle OMQ is equal to 180 degree. OMQ you write or you write QMO, both of them are same. We know that PMO and QMO are equal. So instead of PMO we can write QMO, or instead of QMO we can write PMO. So I am writing angle PMO plus angle PMO is equal to 180 degree. Means I have replaced OMQ with PMO. So 2 times of angle PMO is equal to 180 degree. So angle PMO is equal to 180 upon 2 is equal to 90 degree, and angle PMO is 90 degree. Since angle PMO was equal to QMO, implies that angle QMO is also equal to 90 degree. Hence that was your proof. So hence proved. So what we this you always remember, that whenever a straight line bisects a chord, whenever a line from the center, whenever a line from the center bisects a chord, then it is always perpendicular to the chord. This statement you need to remember, so to solve the questions. Most of the questions are based on the same statement. What is the statement? If a line is drawn from the center and it bisects a chord, if it bisects the chords, then it is perpendicular to the chord, or its converse. What is its converse? That if a line from the center is perpendicular to the chord, then it bisects the chord. Means it's reciprocal. Let's talk about its converse. I'm not rubbing all this. I'll solve it here only. Converse. What is the converse? Converse is if a straight line is drawn from the center and is perpendicular to the chord, then it bisects the chord. Means now this time what is given? These angles are given, and you have to prove that PM is equal to MQ. And what is given? These angle given is angle PMO is equal to angle QMO is equal to 90 degree. In the converse, what it will be given that these angles are 90 degree, that is given, and we have to prove that PM and MQ are equal. So how will we prove? First point, these angles 90 degree, second these are radius, and third this side is common. So right angle, hypotenuse side, right angle, hypotenuse side, triangles congruent, so PM is equal to MQ. I'll write it over here. First point, we can say that PO is equal to OQ because they are radii. Second point, we can say angle PMO is equal to angle QMO is equal to 90 degree. And third point, OM is equal to OM common, and this is given. So we can say that triangle PMO is congruent to triangle QMO. Reason is RHS. Therefore we can say triangle PM, therefore PM, not triangle, therefore side PM is equal to MQ by CPCT. So we have also proved that if a line is drawn from the center and if it is perpendicular to the chord, then it bisects the chord. So these two theorems which are converse of each other, if a line is drawn from the center and it bisects the chord, then it is perpendicular to it. Or if a line is perpendicular to a chord, then it bisects the chord. These are the two theorems that we have taken up, and you need to remember both these. If this is there, then this is also true. If this is true, then this also has to be true. So now we move on to the next theorem. Let's see what is there. So I hope this is clear to you. Now I am ending this class. Two more theorems are left that will be taken up in the next class, and then we'll continue with the exercise, that is 15.1. So I'll try to take up almost all the questions so that your concepts are clear. And till then, keep on studying, keep on watching, and stay blessed. Thank you, all of you.